gentlemen, here we are, and we are looking at chemistry 2019, Kcse 2019, chemistry, paper number one. And I would want us straight away to have a look at the paper. For those of you, of course, who have never met me, my name is Dr. Joshua Aura. I teach at RCM College. It's called RCM. We don't go by any other brand name. It's called RCM Online College or RCM College, like that. I did CPS. But now I have, in this case here, also stepped down. I've come down one step to high school. I would want to help high school students get an A in their mathematics, physics. We have chemistry and biology. So then I'm coming in this case here to step in to ensure that you guys are able to get those great grades. We must get our A's here. So today I want us to go to topic number 1 in Form 2. That's a very important topic. Form 2, chemistry. Topic number 1. Is there somebody who can give us the name of that topic? Topic number 1, Form 2, chemistry. Is there somebody who could be knowing? Can raise your hand and I'll be able to unmute you guys to talk to us. Can raise your hand. There is a way you raise your hand here in Zoom, like Sharifa. Yes, Sharifa, are you able to unmute yourself?
Chemical families.
Chemical families. Let me get another person in this case who is able to remember, who is able to remind us. Someone else who has a different opinion. Someone else with a different opinion. Regarding topic 1 in chemistry, very, very important really topic, a very, very important really topic. So I'm looking for people really to give presents. Yes, Mary?
Structure of an atom.
Structure of an atom. It's really like a subtopic, but thank you very much. Great. So then, ladies and gentlemen, I can see you guys have an idea, and indeed, I should even be able to do what here to reward somebody. I should be able to reward somebody. So, ladies and gentlemen, this is what we are doing here. I would want to come here and share this question paper with you today. Serious presence. Of course, this is the first time I'm teaching most of you. You know that when it comes to presence, I'm a serious person. All right. Ladies and gentlemen, you are told here this is Kcse, Kenya National Examinations Council, Kenya Certificate of Secondary Education. You can see chemistry paper 1 theory, not practical. Its code is, as always, since I was a student, its code has always been 233/1. You are given always 2 hours, and you need to fill this name, index number, candidate signature, date, etc. Instructions are given there very clearly. You don't want to go through instructions. You want straight away to attack the paper here. So you're told an atom of element has a mass number of 39 and 19 protons. So they want me to write the electron arrangement of the atom. They want me to write the electron arrangement of this atom. So, ladies and gentlemen, how do we get this electron arrangement or configuration? Very easy. Since the time I was taught this in those good old days, that's why I remember my high school days with a lot of nostalgia when I was a good student, an A student. All right. So in this case, I remember this concept. First of all, we normally talk of what here? If the neutron, assuming, of course, we know that inside here we have protons, we have in this case here neutrons, we have in this case here what here? Electrons. Assuming, ladies and gentlemen, I'm just making an assumption that we only in this case here had protons, which are positively charged particles in this atom, positively charged. Assuming in this case we had only this, and then of course we had electrons. Of course, electrons are supposed to be out, assuming they were there. If in this case here, ladies and gentlemen, so these are 3 negatives, these are 3 positives. For it to be neutral electronically, or rather, for it to be a neutral atom. If it's a neutral atom, we are supposed to have here our concept of nope equals no. If it's a neutral atom, ladies and gentlemen, we are supposed to be our number of protons should always be equal to number of what here? Electrons. Number of protons should always be equal to number of what here? Electrons. See how I'm writing this E with a bar. Electrons, of course, it's very important for us to get used to the symbols of our nomenclature. So in this question, they have told that the mass number is 39. The mass number is 39, and the number of protons are how many? They are 19. The number of protons are 19. Let me repeat this. I mean, anytime I remember this, like, nope, equals no. I'll be able to write here in full now. Number of protons should be equal to number of what here? Electrons. I started by telling you, I'll be going deeper into this. But I just wanted to look at a simple structure where we have, neutron means what here? Like when you have a positive, and then you have a negative, 1:1, or 2 positives, 2 negatives. That means 2:2. Like these are 3 positives, 3 negatives. In this case, and then this atom will be said to be well balanced. If it's well balanced, it means that it is what here? It is neutral. It is neutral. It is neutral. Ladies and gentlemen, please listen and listen to me very well. This Kcse question was a straightforward question, and it was an easy question. So they have told us here, an atom, this atom called A, has a mass number of 39 with how many protons? 19 protons. They want us to write the electron arrangement of the atom. They want us to write the electron arrangement of the atom. So the very first thing that I need to do then to be able to get this electron arrangement or electron configuration, I need to know the number of what here? Electrons. And yet they have not given me the number of electrons. These guys have given me number of what here? Protons. So then the very first thing that we needed to have done here is to remember this neutral atom, where in this case, the number of protons should be equal to number of what here? Electrons. But how many protons do we have in this case? How many protons do we have? This question, how many protons do we have? How many protons do we have in? Please type there. How many protons do we have in this case? How many protons? Please remember, the more the questions you answer, the more the gifts you'll be able to get. And at times, in this case, you can raise your hand up. If you raise your hand up, I'll be able to select you guys. So Yvonne, Byron, they're telling me that we have got a number of protons in this case here, they are telling me they are 19. But you're saying that then they must be equal to number of electrons, be equal to somebody here, 19. Please listen. I want to be very clear. Whenever we have, and in this particular case, you have just told me that number of electrons will always be equal to number of what here? Protons in a neutrally charged atom. So then, having known here, you can come and tell us that therefore number of electrons are how many? They are 19. Number of electrons are 19. So up to here, first of all, are we together up to here? Because the moment you understand this topic, really, you'll have understood like the entire chemistry. There is nothing in chemistry that will ever be a problem to you. Byron is telling me this is okay today. Byron should be able to get my present because he's a serious ninja who knows how to use emojis, emoticons, emotions, coming from the word emotions. All right. So number of electrons, ladies and gentlemen, in this case here, they are what here? They are 19. I'm being told here that they are what here? They are 19. And then now my teacher in those old days told me, leave so many stories. To be able to get the number of electron arrangement, having known the number of electrons that you have, having known the new, always come and draw a staircase. You draw our staircase. Remember, number of electrons normally follow the staircase approach. So our first step, remember how a staircase looks like. Our first step here will always have 2. All the subsequent steps will have how many? Electrons. All other subsequent steps will have 8, 8. Yes, I can see Byron already has gotten an answer. So remember, the first step will always have 2. All the subsequent steps in this case will have 8, 8, 8 up to infinity. Number of electrons like that. So then our work will be to be able to fit in 19 into our staircase. We want to fit in 19 into our staircase. So when we do this 2 plus 8, this gives me 10 cumulatively. 10 plus 8, this gives me what here, somebody? 18. So for us to be able to reach 19, then the last staircase will have how many electrons? The last staircase will have how many electrons? The last staircase will have how many electrons? One. The last staircase will have 1 electron like that. 1 electron. Because you want to account for what here? We want to account for 19. We want to account for 19. We want to account for 19. So, and therefore, the moment I can see now my staircase in full, in short, I'm able to see the configuration of electrons here. So the configuration of electrons here, or the electronic arrangement, will be 2:8:8:1, because I can see this. If you add this, you will get 90. You will get 19. If you add those ones, you will get 19. I don't know whether we are together really. I would want us to be very, very together in this. I would want us to be very, very together in this. It is all about, ladies and gentlemen, in this case, you're seeing the staircase, like the ones you use at home. Remember, the first staircase is a baby's case, where a baby can just go up, just like 2 centimeters. But now from there, they would expect you to eat some Cerelac, and of course, have in this case here some stamina to be able to do a bigger staircase now. But you'll be doing now a staircase of 8:8:8:8:8 like that. Now, ladies and gentlemen, this seems very easy. Let me see whether you guys will be able to get this. What if, for example, we had this kind of a situation? What if, for example, ladies and gentlemen, we had a number of electrons? What if we had nu of just 7? Nu of 7. Who is able to give me the electronic configuration very fast without even thinking? Using the staircase approach. Using the staircase approach. 2:5, yes. Because you see, the first stair will always be 2. The first stair will always be 2. Now I'm trying to go to the second stair. You see, the second stair will have 8. But if I do 2 plus 8 cumulative, I will get 10. Which will be, in this case here, more than what here? More than 7. So I need to ask myself then, if this is way higher, then I will wrap this 8 right first, and then ask myself, what balancing figure do I put here, so that the 2 staircases then will be able to give me 7. So it will be 2 and what here, somebody? 2 and 5. 2 and 5. And therefore, the electronic configuration or electronic arrangement, the examiner will be using the word electronic arrangement, the word arrangement and configuration interchangeably. So then this, at the end of the day, will be 2 is to what here? 2 is to 5. This will be 2 is to 5. This will be 2 is to 5. So is that okay, ladies and gentlemen? Is that okay, ladies and gentlemen? Let me try you with one. Let me try you with one here. What if, for example, you have, I'm so sure nobody will be able to get this right. I'm 100% sure nobody will be able to get this right. What if, in this case here, our number of electrons is 27? Are you able to give me the electronic arrangement here? Are you able to give me the electronic arrangement? Let's see which ninja. Do I have some M-Pesa on my phone here? We should be able to give the first ninja here something. We should be able to give the first ninja here something. We should be able to give the first ninja here something. We should be able to give the first ninja here something. The first ninja something. We should be able to give the first ninja something. We should be able to give the first ninja something. The first ninja is getting, the first ninja is getting something here. Let's see, ladies and gentlemen, let's see this together. Oh, I wanted to just get like, who is the very first one then to get this right? They get a present. You need to give a present here, a good present here, a good present. 2, 8, 8, 9. No, Becky, remember the staircase, the highest width of a stair can only be 8. It can never go to 9. So in this case here, remember how you move along the stairs, how you move along the stairs. So we start with the 2. 2 is the child's stair, the child's stair. That has to be very small. The first one has to be very small to accommodate everybody, So we have 2 there. After 2, ladies and gentlemen, now we know that the other staircases will be what here? Will be 8, 8. So remember, so far I've done 2 plus 8, that is 10. 10 plus 8, that is 18, yes. So 18, I'm quite close to this. So from there, I'll be able to take on another stair of 8, isn't it? Which takes me to 21. Remember, you're doing cumulative. So 2 plus 8, that is 10. 10 plus 8, that is 18. 18 plus 8, that gives me what here? 26. So it means that now the last staircase cannot take another 8. The last staircase can only take what here, somebody? Can only take 1 to accommodate, to be able to account for the entire 27. To be able to account for the entire 27. So then, ladies and gentlemen, it means that the electronic configuration here will be 2 is to 8 is to 8 is to what here? 2 is to 8 is to 8 is to 8 is to 8 is to 1, like that. Is there anybody who got this right? I just want to know. Is there anybody who got this right? 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 Okay, the most important question, ladies and gentlemen, is there somebody who has gotten some new concept out of this, out of whatever you've done? Is there somebody who has gotten some new concept? Of course, I know you have done it in school, but is there somebody who has been able to get like some new kind of perspective of looking at this? Some new kind of perspective of looking at this? I'm happy to see that. When you go back to school, you'll be able to tell your colleagues that, you know what, at least I've been able to know this thing even in a better way, Then if you allow me, ladies and gentlemen, before I throw around the present, I would want you to come here and look at part B. So state the period and the group to which element A belongs. So you tell us the group, and then you tell us the period. So in this case here, we have 1.5 mark. No, it's a half a mark. So state the period and the group to which element A belongs. So abracadabra, what are you able to see there pretty fast? Abracadabra. What are you able to see there pretty fast? We start with, of course, in this case here, we shall start with the group, right? Let's start with the group, isn't it? Let's start with the group. So most of them are telling me that this is group what here? Group 4. They're telling me it is group 4. They're telling me it is group what here? It is group 4. Abracadabra. Group 1, period 4. Now I can see great students are coming up now here. Ladies and gentlemen, they're telling me in this case here, we have group 1, period 4. Now students are talking to me very nicely. Students are really following here. So I'm still giving them some more time in this case here to reason this out, and then we should be able to do it together. But of course, as we do this, ladies and gentlemen, I would want to welcome all the students in this case here who are doing these sciences, who are doing chemistry, physics, who are doing, in this case here, biology and mathematics, to join RCM's virtual online tuitions, Kcse students, Form 4. In this case here, we teach Form 3s, we teach Form 2s, we teach Form 1s, and our classes, of course, we put those groups in their own respective classes, from Form 1, Form 2, Form 3, and Form 4s in their own classes, right? And of course, in their own classes, now we are able to go straight away, like now what I'm doing here. If it's topic number 1 of Form 2, we shall be able to tackle revision questions here. We shall be able to revise things here. So you need to join us, and to join us, of course, what we need to do is to pay us fees. For the 3 weeks, we are charging Kenya shillings, you're charging Kenya shillings 1,200 per paper. 1,200 per paper, 1,200 per paper. I can see my internet is not very, very stable, but we shall overcome. But are you able to hear me? 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 I can see signals telling me that my internet is not very nice. But we shall overcome, isn't it? We shall overcome. What I'll do, anybody whose video is on, anybody whose video is on, first of all, tunamtoa hapo sasa. Now, ladies and gentlemen, mentioned there that a group is determined by the number of electrons. A group is determined by the number of electrons. A group is determined by the number of electrons at the outermost energy level. At the outermost energy level. At the outermost energy level. In my case, we use the concept of what here? The top step. The top step of our staircase. The top step of our staircase. The top step of our staircase is what gives us, ladies and gentlemen, in this case here, our group what here? Our group level. Is what gives us our group level. The top step, the energy level, the number of electrons that you have at the very top step is what gives us the group level. So remember, our number of electrons were 19. So in this case here, we began with 2. Then we went 8. Then we went 8. So this is 10. 2 plus 8 is 10. 10 plus 8 in this case here is what here? Is 18. So then we have, in this case, we are only left with 1. So the last stair, in this case here, is what here is 1. So ladies and gentlemen, please remember this is the top staircase. The top staircase. And it is in the top staircase that you normally get what we call a group of schools. Just for you to remember. For you to remember. It's at the top where we have what we call a group of schools. It's at the top staircase. So the number of electrons that you have here at the top staircase is basically what defines your group. So basically this atom is in a group what here, somebody? This atom is in a group 1. The atom in this case is in a group 1. The atom in this case is in a group 1. So the atom is in group 1 like that. The atom is in group 1. The atom is in group 1. Now please listen and listen to me very well. What if we had a number of electrons in this case here, ladies and gentlemen? If number of electrons here, let me go back to what we have done with you. If number of electrons were 7, if number of electrons were 7, then this atom here would have been would belong to which group? Would belong to which group? Abracadabra, these guys are not talking to me. Would belong to which group? Group 5, isn't it? Group 5, because what we only need to do, ladies and gentlemen, is to come and draw the staircase for this. Draw the staircase for this. So, and as we draw the staircase for this, the very first stair will have to the same 10. That will be surpassing this 7 is quite low. So I'm looking now for the balancing figure. Balancing figure will be 7 minus 2, which gives me what here, somebody? Which gives me 5. So in this case, ladies and gentlemen, then the group for this atom will be what here, somebody? Will be 5. Are you aware that we are supposed to be writing the group numbers using Roman letters? Or you can just write anyhowly. I don't know, maybe during your times. I don't know. But during your times, in this case here, it's supposed to be, if it's Roman 1, like that. All right, I can see it is the same still. It is the same still. Yeah, it is the same still. Great. Now, ladies and gentlemen, from there, I would want us to look at the period now. Let's look at the period. The period. It is still the same. Then things have not changed. Then it means that I should be able to teach chemistry. Can I make a good chemistry teacher? Can I make a good chemistry teacher from your assessment? From your assessment of Mwalimu? Can I make a good chemistry teacher? Oh, great. because I'm using terminology like group of schools, highest step level, highest step level, highest step level. All right, okay. Then we shall overcome. 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 Thank you so much. Now, ladies and gentlemen, from there we come back to our question. Remember now we are looking at, ladies and gentlemen, the periods. Which period does it belong to this atom here? If you look at the question, let me go back to the question. I can see they're saying period 2. FCPA Nyamolo, great. FCPA Nyamolo has a daughter or a son here. So state the period and the group to which element A belongs. So in this case, the period, what period are we belonging now here? Let's look at 19. Remember, our electrons were how many? Our electrons were 19. Our electrons, knew like this, 19. So, and we were able to draw our staircase. We were able to draw our staircase. We went to 8. From 8, we went to another 8. So 2 plus 8, that is 10. 10 plus 8, that is what here? 18. Then we had in this case here one last step of what here? Somebody? Of 1. So then, ladies and gentlemen, out of this, remember we have our nomenclature, or rather our configuration was 2, 8, 8, and what here? Somebody? And 1. And 1. So is there somebody who is able to give me the number of periods here? Is there somebody who is able to give me the number of periods here? Is there somebody who is able to give me number of periods here? So remember number of periods, and I would want you to write this there about number of periods so that you'll be able to know how to define this very well. That periods are determined by the number of occupied energy levels. They are determined by number of occupied energy levels. Occupied energy levels. Occupied energy levels. Chemistry, we are doing chemistry, Jessica, don't worry, and you're almost finishing. So in this case here, occupied energy levels. So the occupied energy level, this level 1, level 2, level 3, level what here? So in this case here, the period, we are talking of period what here? We are talking of period 4. Period 4. Or in my case, 4 staircases. So we have staircase 1, staircase 2, staircase 3, staircase 4. There are 4 staircases there. There are 4 staircases. So anytime we talk about periodically, I imagine myself walking on these energy levels. So 4 energy levels. So I should never confuse a group of schools, the top staircase, with the periods. Period 1, period 2, energy level 2, energy level 3, energy level 4. So I hope with that, you guys will be able to really distinguish this in your exams. Is there somebody who has been able to master something there now, something a little bit amazing? It could be that you knew, but at least you've been able to get something from a new perspective. Yes, Ninja. Great. No, in this case here, protons are not at 9. That's just mass number. It was putting that at 9 there too. Yeah, it was putting that mass number at 9 to confuse you. Great ninjas. Now, I need, ladies and gentlemen, to get a present for just one of you. Just one of you. Today, I'm not giving so many presents. A present here for just one of you, who will be able now to come and state whether this atom is a metal or a non-metal. And then we give them a present. State whether the element is a metal or a non-metal. I'll give you exactly 5 minutes. You try giving me this, and then I give you a present. Great present, I tell you. Hey, Jambo, how are you? Good, tunang'ang'ana tu hapa. No problem. Yes. Anafanya which course? You know, communication if I were you, nampeleka kwa Toastmasters. Have you ever heard of Toastmasters? It's a British organization kubwa. Utawapata wanafunza watu how to speak and speak out, and then how to be a good leader. And then they will teach him how to be very organized. They charge about 1,000 a month. It's a lifelong. Akianza kusoma atakuwa elite permanently. Inamsaidia sana kwa kosi yake. No. Most of the classes unafanya online now. Alafu unajua most of them the project unapatiwa. Alafu unakuja kupresent. Yes. Toastmasters kama mkata. Mkata alafu master. Toastmasters. Thank you very much. All right, so let me see your arguments. Let me see your arguments. They're saying metal. All of them, they're saying metal. All of them, they're saying it's a metal. It's a metal. It's a metal. All of us are doing very well. All of us are doing very well, ladies and gentlemen. It belongs to, Amali, you're confusing. Remember the question you're answering is this question here. This question here, the one that is in our paper. So you don't bring the one of 7, it's the one of 19. It's the one of 19. Now, ladies and gentlemen, remember, what you're supposed to recall pretty fast, is that for you to be able to classify an atom to belong to either a metal or non-metal, or what we call a metalloid, what we do, we look at the group number. Which group do we belong in? Which group do we belong in? Which group do we belong in? So in this case here, remember, we have 2 classifications. There are 3. Categorically, broadly speaking, we have group 1, group 2, group 3. So if you have an atom belonging to any of the groups here, automatically that atom, in this case here, will be what here? Will be a metal. Of course, metals have tendencies of losing what here? Electrons. Will be a metal. And then we come and look at this other category. This other category, we start from group 5. Group 5. We have group 6. We have group what here? 7. So now these are non-what here? These are non-metals. Non-metals like that. Non-metals. And remember, the question that we are handling is a question with a number of electrons. Number of electrons are 19. And we've been able to know that this particular atom is in group what here? Somebody is in group 1. And since it belongs to group 1, then automatically that particular atom in this case here is what here? This particular atom here, this particular element is what here? Is a metal. Is a metal because it is in group 1. So if you got in this case here any element, any atom in this case here that has that is in these groups, automatically that element will be a metal. Right? In this case here, then we have these other groups. If, for example, you have like what we had here, number of electrons 7. So 7, when you try in this case here doing the configuration, this will be 2 is to what here? Is to 5. 2 is to 5. So that tells me that this particular one, if you put on your staircase, the group of schools, the group is 5 here. And if the group is 5, ladies and gentlemen, then we are here. Then this would have been what here? A non-metal. A non-metal. What if in this case here you have an element which automatically belongs to group 4? Which automatically belongs to group 4. What if you have an element which automatically belongs to group 4? Can somebody in this case here talk to me? Where will you be able to classify this? Because group 4 is neither here nor here. Yeah, they don't lose to become stable. Yeah, it is group 4. What name will we give in terms of Metalloids. Thank you. Not noble gases. No. Group 4, we call them, group 4 in this case, now they are in between. These are in between. They can lose to gain, to become stable. They can lose electrons to become stable. They can gain to become stable. So in this case here, they are in between. And whenever they are in between, these group 4 members, we shall always call them metalloids. Metalloids with double L, metalloids like that. Metalloids like that. So then what I will do, this person who spoke about metalloids at first should be able to give me his phone number here. The guy who spoke about metalloids should be able to give me his phone number here. We give them a present. Metalloids. First of all, we work with metalloids first. We give them that person who spoke about metalloids. That does he have? He doesn't want my present. This ninja 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 doesn't want my present. So, ladies and gentlemen, that marks the end of our chemistry today. I'll not be able to do mathematics now, not unless you tell me that you guys will be studying at your own up to what time. Maybe I can come later to do 1 or 2 questions, mathematical questions. What is, in this case, your very best time for mathematics? What is your very best time for mathematics? At least here we've been able to lay something. But later on, I will also be coming with Form 3 stuff. More actually, all right? And then we shall be looking at the simplified way. Like in this case, this concept of the first 21 elements. Do we have I would want to welcome all of you to join our classes, You can't go wrong by joining our holiday classes. You've got everything in this case here to do what here? To gain. So I hope that is okay. And I hope, ladies and gentlemen, there is somebody who has gotten, in this case here, some great concepts out of this. These free of charge classes should be very short. They should be very short so that you guys now can get an appetite of joining us. And of course, if you want to join our college and study online, holiday tuition in a very, very simplified way, you simply need to call our number, which is 0793 555 000. 0793 555 000. So can we stop there, ladies and gentlemen? Are we okay now? The only thing you haven't told me is what time should we come back for mathematics? What time? What time should we come back for mathematics? Now, I would want also you guys to take time to study. My students, one thing that I do is to encourage them. Take time to study. I should not just come at 7. 7, you guys won't have taken time to study by yourselves. Like if I were you, I would just go and draw this Form 2 book and just learn this entire concept afresh. Get to know in this case here what is a proton, from the word proton, positively charged. What is an electron, neutron, etc. All right. Then I'll be a very good student. I will be a very good student. Paula is saying 7 to 9. I think 7 is good. 7 is good. So then we shall be able to meet at 7. But again, ladies and gentlemen, please ensure that you are supporting us by bringing your friends at that time, 7. So Paula, I can do those 2 hours, 7 to 9. But depending on the number of students I will get here. If I get so many students coming to attend that one, then that will be very good. Otherwise, thank you very much. See you at that time. Sasawa. There is somebody alipata kakitu, even 11 will be very, very good. There is somebody alipata kakitu na nataka kusema namba yake sijui kwa nini. Huyu ninja huyu sasa tuachane na yeye. Nimempembeleza sana, hataki pesa. Ama Byron akule on his behalf. I think Byron akule on his behalf. Byron akule ni nana kweli? Wametuma wawili. Wametuma wawili hasa kwa jua ni ngumu hawa. Wametuma wawili. So ladies and gentlemen, let's take all those gifts today at 7 p.m. Keep time. There is one who has inboxed here. Now wamekuwa watatu. watatu. Keep time 7 p.m. 7 p.m. Byron sasa wamekuwa watatu. Tuache hiyo. Link nitatumia link mapema Jessica. Nitatumia link Jessica mapema sana. Thanks for asking because I know you want to bring in most of your friends at that time. You want to bring in most of your friends at that time. Phyllis, we shall overcome, don't worry. I'll do something then at 7, Phyllis. Bring most of your friends. Bring most of your friends. Thank you.